So first off, what's on the test? It's with calculator. We haven't had one of those in a while. I don't know if we've ever had one of those yet. And that will be, the calculator is necessary on a couple of them, 2 or 3 of them, not many of them. But those necessary meaning those optimization ones that get weird numbers and big numbers that you don't really want to mess with without a calculator. So it's necessary for those. It's helpful on a few others, and like helpful in such a way that you can answer the question with the calculator even without knowing some of the calculus. You know what I mean? Like if you graph the thing, you can find stuff without actually knowing the calculus. That's very few of them though, so I'm not really worried about those. And then there's a couple that are free response that, yes, you could use the calculator, but if you don't show the calculus to back it up, I'm not going to give you full credit. So by all means, use the calculator to confirm your calculus, but don't just rely on the calculator. All right, here's what the sort of the breakdown is. Given a graph of f prime, do a graph of f. That's the first question on the test. I kind of don't like that I put it as the first question on the test because I feel like it's one of the harder ones. So you might just skip that one and come back to it. I think that would be my recommendation. Not that it's hard, it's just there's a lot going into that. You have to look at, well, where is f prime positive and negative? Where is f prime increasing and decreasing to get f is concave up, concave down. So I would probably wait till the end to do that one after your brain is fully warmed up and thinking about things. I'll try to remember to say that again tomorrow as well. 8 multiple choice. Most of those are about the relationships between f prime and f double prime. Meaning if f prime is increasing, that means that, you tell me, if f prime is increasing, what does that mean? Okay, careful. If f prime is increasing, f double prime is positive, which means f is concave up. You wouldn't say f double prime is concave up. That would mean like the fourth derivative is positive. So you combine like different things there.
Is this not the same stuff from the last test?
Yes, and remember, I'm glad you asked that. This test can replace the last test because there's a lot of overlap.
Yes.
No, it doesn't. It doesn't go the other way. Here's why not. This test, last test. All right, so this test covers more than what was on the last test. So if you do well on this test, we can cover up last test. But last test didn't cover everything that's on this test, so it's a one-way grade substitution possibility. One, given f of x equals something, find everything, and by that I mean that one-page worksheet where like the one problem was the whole page, and you found the first derivative, and then where it was increasing and decreasing. You found the second derivative, concave up, concave down. Found the intercepts, and then like put all of that stuff together and did a graph. You know what I'm talking about? One of those.
Does it like tell us what we need to write?
Yeah, it looks exactly like, it's exactly like the worksheet with a different function at the top. So it doesn't just say here's the problem, do everything,
Okay.
right? It says here's the problem, and then it walks you through all those same steps.
So is it like one question but with like many things in it?
Yeah, like the point value it's a lot of points, but it's not an all or nothing thing. Like all of you, 95% of you are going to get the points for the first derivative and the second derivative because it's a polynomial, so the derivative's easy.
Oh, wow.
And then set the derivative equal to 0 and so on. So most people do fine on that section. It's just a lot there. But we prompt you for each step of the way, so it's not just, hey, here's a problem, go do everything. 3 optimized problems. But remember, those aren't like 4 points each. Those are like 8 points each because there's so much going on. Set up an equation, take a derivative, set it equal to 0, figure out if it's a max or a min, answer the right question. So 3 of those. Those would definitely be ones where the calculator is necessary. Given the graph of f prime, find, this is basically the same thing that was on the last test, like the last piece of the last test. Find relative extrema, find points of inflection, concavity intervals, etc., looking at a graph of f prime. Just remember, you're looking at a graph of f prime, not a graph of f.
When you say it's the mean, would you say that there's like one graph and then 3 questions?
Yeah, it's very similar to that last part of that last test. I don't know if you remember it or not, where we give you one graph of f prime. And then we can ask, where is there a max? Where is there a min? Where is there a point of inflection? All that stuff. In fact, shall we answer that for this picture right there? It's a pretty simple picture. Let's see. I'm just trying to think of all the different things we could ask for. So is there a relative max anywhere? Well, a relative max of f. I guess we should specify. So x equals 2 is a max of f prime, but are there any maxes of f? A max of f would be where f prime changes from positive to negative, so no. Any relative mins? X equals 1. What's the justify for that? And you have to write that out. You can't just like circle it or say, well, I know it. You have to say f prime changes negative to positive. That would be a min. Where is f concave up? We'll say this function is only defined between 0 and 4. That way we don't have to worry about infinities. Well, it's not an x equals. It's an interval.
0 to 2.
Good. 0 to 2. And 3 to 4. What would be your justification for that? F prime is increasing. And then f is concave down. 2 to 3. Because f prime is decreasing. And then those sort of go together. Where is there a point of inflection? X equals 3. And why?
Concavity change.
Yeah, you could just say concavity changes because you've already made the case about concavity. So again, I feel like those aren't hard. We've done a bunch of them, but you've got to remember and train your brain to think, I'm looking at f prime. So it's really hard to, or maybe you're getting better at it, but when we first did this, when you see relative max, your brain knows what a max is and it immediately jumps to x equals 2. But that's not what we're talking about, the relative max of f. This is not the picture of f. This is the picture of f prime. So that's what makes these sometimes tricky. And then lastly, given a table of f prime, f double prime, do a graph of f. And we did several, or at least one worksheet, sort of like that. F prime is positive, F double prime is negative, and so concave up, concave down, increasing, decreasing, all of that stuff. All right, what's due is 5 of these 6. And a bunch of these we did in class, so this should be easy for you. I think it's all 6 things that we've done. There was a worksheet on function analysis. There was a worksheet that was called data representation. That was given the tables, draw the graph. There was an optimized worksheet that we ended up doing most of them together. There was the quiz, non-quiz that you did yesterday. Called a quiz, but not a quiz, kind of a thing. I gave you a review. And I don't know what to call it other than the one long problem, or the 1-page problem, where I gave you the one equation and we did everything with. We ended up graphing it, but we had to do 14 things along the way. Connor, that one right? Yeah, that one. Wave that one around. That one. But we did that together as well. So the vast majority of these we've done together. So I hope you have 5 of the 6 already done. We haven't done the review together, but you got it. So that's what's due. So that's the kind of the preview of what's the test will be like and what's due.